type 6. Straight section of a loop is 2a length. That means all the sides are 2a length. The current is I is flowing through the loop. Magnetic field due to this loop at a point P, A, 0, A, point in the direction. They are given the 4 options. In which direction the magnetic field due to this loop at the point P we need to find it. Okay? And changing this loop like this way. This is the Z axis and this is the X axis and this is the Y axis. Okay? So this is the loop. Okay, this through this loop like this, and current is to be going like this and like another loop. Okay. This is the loop. This direction, this direction, this direction, and this direction. Okay. So this loop I was changed to 2 loop. Here current is in this direction, current is in this direction, so the net current is 0. So no issues. This diagram is similar to this. So they told a point that is P, A, 0, A. That means X axis half of it. That means from here, this total distance is how much? This total distance is 2A. Current is 8. So from here, this is the from, this is the point. Okay, in the red point. This is the point P. This point P is, we can take it out. This point P is to be, what you will get? That is P is equal to A, 0, A from this. Okay. This loop will produce a magnetic field at this point, and this loop also will produce a magnetic field at this point. What is the direction of the magnetic field produced by this loop? This loop is in ZY plane. Okay, the resultant magnetic field is perpendicular to this plane, that is along the x-axis. That we can find out by using right hand palm rule. That means you curl your palm in the direction of current and the thumb will give the direction of the magnetic field. So you can see that the magnetic field is along the x-axis. So this is the B1 direction. B1 is a magnetic field due to this loop. This is the first loop and this is the second loop, like that I have taken. Next, this loop is in which plane? That is in XY plane. The magnetic field due to this plane is perpendicular to XY plane. So the direction you can see that. Curl your palm in the direction of magnetic field, in the direction of current. Then the magnetic field is like this. So you see this. This is B2 is along this direction. Okay. This we can take like this. This is a point P. B1 is in this and B2 is to be like this. This is which axis? This is Z axis and this is X axis. So you see this. These two vectors are acting in two different directions. So the net magnetic field can be found out by using parallelogram law of vector addition. So based on the parallelogram law of vector addition, the diagonal of the parallelogram is a net magnetic field. Okay, this is a net magnetic field. So B net is equal to B1 plus B2, B vector plus B2. You see this. B1 vector is in which direction? X axis, and B2 vector is in the Z axis. That means if the two vectors are in a plane, the resultant also in the same plane based on the parallelogram law of vector addition. So these two vectors are in the ZX plane. So the resultant also will be in which plane? ZX plane. So this net magnetic field have only Z and X. That is to be positive Z and positive X component. So which option having the positive Z and positive X component, that is this is the direction. Clear? This is the answer for the type 6. Now we will see type 7. A long wire lying along the z-axis carries a current I in the negative z direction. Okay, current is to be in the negative z direction. The current carrying conductor is in z-axis. The man-field vector B at a point having coordinate x, y on the z is equal to 0 plane. We need to find out man-field at a point having coordinate x, y. Okay, that we have to find. Okay, clear? So, man-field due to infinitely long current carrying conductor is B. That we already find out a formula. That formula is B is equal to mu 0 I by 2 pi R. Okay, 2 pi R. If I am write this in vector form, what you will get, that is dl cap cross R cap you will get. This is the vector form. The direction of B is perpendicular to the plane containing dl and R cap. What is R cap? R cap is equal to R vector divided by modulus of R. This I will substitute here. So I will get B is equal to mu 0 I by 2 pi R square into dl cap cross R vector. Okay, this denominator R come to this R come to denominator. Clear? Okay. What is dl? dl cap having the same direction of current. What is the direction of the current? That is minus z axis. So minus kk. Okay. And what about R vector? They given the point is having the coordinate x and y, that is xi plus yj. What about the magnitude of R? Magnitude of R is equal to square root of x square plus y square. Okay, now we will find out what is dl cross R vector, that we will find. Okay, ijk. So what about the first vector, that is dl? dl is to be 0, 0, minus 1. And what about R vector? R vector component, x component is x, y component is y, and 0. Expand it, what you will get? Expand it, I into rows and columns are cancelled. So this into this, 0 minus this you multiply plus y you will get, minus j into rows and columns are cancelled. Then what you will get? That is 0, 0 again. Minus of minus, that is plus x you will get. Okay, then again what you will get? Again plus k into this rows and columns are cancelled, so 0 minus 0. Okay, so what you will get this, that is yi minus xj. Yi minus xj. This is dl cross R vector. Now you will substitute this in here. Sorry, this in here. So what you will get? B is equal to mu 0 I by 2 pi into dl cross R vector is yi minus xj divided by square root square, that is the modulus square, that is x square plus y square. Okay, this is the man-field at a point having coordinates x and y. Type 8. Two long parallel wires are at a distance of 2d apart. They carry steady equal current flowing out of the plane of the paper as shown. You see here, the distance between them is 2d. The variation of man-field B along x dash is given by, okay, if this is the x and this is the x dash, okay, this is to be the x and this is the x dash. Here also x dash, x dash, which is the correct option. We have to choose it. Okay, so We will draw it. Two current carrying conductor are placed perpendicular to the plane. So that means I am taking a current carrying conductor like this. This is one conductor. This is another conductor. The current is coming out of the plane. This is like this. Okay. So the distance between them is 2d. This is x dash axis. Okay. What about the magnetic field produced by this current carrying conductor? This is infinitely long. The magnetic field produced by a straight current carrying conductor is found out by using right hand thumb rule. Okay. Place your thumb in the direction of current and the curved fingers gives the magnetic field. So the magnetic field here is like this. This is the magnetic field direction. Okay. Okay. The same like here also we can get the magnetic field direction. These all having same amount of current. These two carry same magnitude of current. So you see here the magnetic field is like this, here the magnetic field is coming like this. So at the midpoint, here I will consider as a point. In the midpoint, what about B? The B value is 0 here. Okay, B value is 0 here. And we all know the formula. Magnetic field due to an infinitely long current carrying straight conductor is mu 0 I by 2 pi r. I is the current, r is the distance from the current carrying conductor. That means B is inversely proportional to r. That means the graph, the variation of B with respect to the distance graph is a parabola. Okay, we will get like this. Okay, same we will apply here. So in this region, the magnetic field is due to this current carrying conductor and this current carrying conductor. This current carrying conductor produces magnetic field in this direction, this will produce in this direction. But this magnitude is larger because magnetic field is inversely proportional to distance. So here is the strength of this conductor. That means this conductor you can take it as P and this is Q, like that you can take it. So the P current carrying conductor magnetic field is greater and the direction also similar. So we can get the direction is to be like this. Which direction? Like this you will get. Okay, this is the direction. And what about here? Here in this region also two magnetic field is there. Magnetic field due to this and this, but magnetic field due to this is to be dominating here. Okay, the graph is like this. Here also two magnetic field is there, but this magnetic field will be dominant. So the graph is like this, and here also two magnetic field is there, but the dominating one is this direction. Okay, what about here? Here the magnetic field is this current carry. Q current carry magnetic field is dominating, so we will get the direction like this. Here also the Q is to be dominating. Here P is to be dominating. That means like this. Here is to be P is dominating. This. Okay. This is the variation of magnetic field. In this, which is to be the correct answer? C and D is not possible because the midpoint magnetic field is 0. But there is no portion is to be there in C and D. So C and D is not the correct answer. Then you look at the A. A, the magnetic field is, you look at here. Here it is going like this. But actually we got the magnetic field is like this. So this is not the correct answer. Then I think so B is the correct answer. We will check. You see here. I think let me erase this. If I will erase this and this portion. Okay, and this and this only. So I am erasing this and erasing this. Okay, now you see the direction and this direction all have to be similar to the B option. So B is the correct answer for this type. Okay, this is about type 8.
Thank you for watching the video. Please subscribe my channel. If you like this video, please put like